Hi Geometry, welcome back. Here's 2.2, analyze. If one's true, what's the statement that's not true? So this is there's gonna be a little bit of writing involved in this section, but don't fret. So if this video might seem intimidating because I have to do a lot of writing or just because of the length of time, it's not that big of a deal. Also, I realized when I looked at my video manager, section 1.6 was only 3 seconds long, so I have to redo that one. Well, here we go. I can write conditional statements, and I can write biconditional statements. So bi usually means two. Here we go. Let's start. A little bit of a warm-up here. Determine whether the statement is true or false. If yesterday was Wednesday, then today is Thursday. That's true. You will be doing this throughout geometry and all of your other future math classes. So determining if statements are true or false. If an angle is acute, then it has a measure of 30 degrees. This is actually false. The reason why it's false is the angle could be 50 degrees. So it's not always true. So you got to be really careful with some of the words here. If an even number, is not divisible by 2, then 9 is a perfect square. Oh, this is false. Why is it false? This part right here. All even numbers are divisible by 2. Okay, now think about it. In order to make any number even, you can always multiply it by 2. Well, if you can multiply any number by 2 and it becomes even, we can also divide each one of those by 2. So this always guarantees an even number, 2n, whereas 2n plus or minus 1 will always guarantee an odd number. That's something to keep in mind in the future. All right, here we go. Conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. This will come in handy when you do AP statistics. When a conditional statement is written in the if-then form, the if part contains the hypothesis, and the then part contains the conclusion. Here's an example. If a person is on the baseball team, then they have practice today. So there's your hypothesis, there's your conclusion. Conditional statements can be true or false. To show that a conditional statement is true, you must prove that the conditional statement is true every time the hypothesis is true. To show that a conditional statement is false, you need only to give one counterexample. All right, so example 1, rewrite the conditional statement in if-then form. It says, you are in Texas if you are in Houston. So, if you are in Houston, then you are in Texas. Make sure those are capitalized. All 120 degree angles are obtuse angles. If the angle is 120 degrees, then the angle is obtuse. All right, so not too bad. Definition. The negation of a statement is the opposite of the original statement. So here's an example. He scored a hat trick. Negation is he did not score a hat trick. So notice the inclusion of the word the inclusion of the word not. Statement 2. She did not pass the quiz. Well, now what's the opposite of that? She did pass the quiz. So we just have to make it right or wrong. So, example 2, write the negation of the following statement. It is not snowing. Okay, right now it's July. So the negation is, it is snowing. So far, so good? All right, got 2 more pages. Not a big deal. Some more definitions. Okay, you're actually going to have to know these. So write the converse of a conditional statement. It's exchange the hypothesis and conclusion. So basically, these will switch. Okay? To write the inverse of a conditional statement, negate both the hypothesis and the conclusion. So you don't switch them, you just write not for both of those. To write a contrapositive, you write the converse, okay, so you switch them around, and then you negate both. So, and then you'll also switch them. So hopefully that makes sense. A conditional statement and its contrapositive, I wonder if that should be apostrophe, are either both true or both false. Similarly, the converse and the inverse are either both true or both false. Pairs of the statements such as this are called equivalent statements. All right, so here we go. Write the if-then form. The converse, the inverse, and the contrapositive of the conditional statement. Hockey players like to fight. Decide whether the statement is true or false. So, first of all, the if-then form. If you're a hockey player, then you like to fight. So now the converse. So the converse, remember what we have to do, we have to switch those. So the converse, let's do this in a different color. You have to switch them. If you like to fight, then you're a hockey player. Ooh, crazy why. Okay, now the inverse. Remember what the inverse does. The inverse, you just negate the hypothesis and the conclusion. So remember, we have to go back to this and negate it. If you are not a hockey player, then you do not like to fight. So let's go back to red here. I know this is ridiculous, but it's just an example. And then contrapositive, we have to flip them around and negate them. So basically, you're going to take this and flip them around. If you don't like to fight, then you are not a hockey player. There you go. So that's an example of your converse, inverse, and your contrapositive. So short and sweet, and it's just a little bit of writing. So use your best handwriting. Okay, Alex? Definition. If two lines intersect to form a right angle, okay, see that little tiny box there? It's in green on my page. I wonder if I should, I'm going to just make it a little darker here. Then they are perpendicular lines. Okay, so the first thing I want you to note right here, see this symbol right here? That's your symbol for perpendicular. And you'll recall from algebra, perpendicular means they form right angles. Which equal 90 degrees. Okay? So the converse, remember, you have to switch them around. So if two lines are perpendicular, then they intersect to form a right angle. Okay? So that's going to come up a lot in our writing of proofs. Okay, so let's look at example 4. We're almost done. I promise. Decide whether the statement is true or false. Okay, segment AB. perpendicular segment BC. Okay, they look pretty good, but we're missing one little thing. That little thing is this box. So this is actually false. The reason this is false is because that symbol is needed. Now, on tests or quizzes, if that symbol is missing, clarify with your teacher to see if it's supposed to be there, okay? Because sometimes, you know, the printer doesn't come out or who knows. But verify if that's supposed to be there. Another definition. Here we go. Write a conditional statement and its converse are both true. When a conditional statement and its converse are both true, you can write them as a single biconditional statement. It contains the phrase if and only if, okay? I abbreviate that like this. IFF, if and only if. So here's an example. Definition. If the sum of the measures of two angles is 180 degrees, then the angles are supplementary. Converse. If the two angles are supplementary, remember converse, you switch them around, then their sum is 180. Biconditional. The sum of the measures of two angles is 180 degrees if and only if the angles are supplementary. So it's just basically putting them together. So you have the if and only if part right there. All right, example 5. Rewrite the two statements as a single biconditional statement. A rectangle is a quadrilateral that has all perpendicular sides. If all the sides of a quadrilateral are perpendicular, then it is a rectangle. So the quadrilateral is a rectangle. My handwriting's getting crazy. If and only if all sides are perpendicular. And like I said before, you can't see that. Lots of teachers will start using symbols. They won't even write perpendicular. They'll put that there instead. So here's your homework assignment. Everyone have a nice evening.